Okay, so this circuit is given. We need to find the value of V1 and V2. We will use KVL and Ohm's law for that. So let's first assign a current and a direction. Let's say this is the counterclockwise, the direction of traverse, and let's say I is the current. So I goes this way and then like that. So first, if we write KVL in the loop and the direction is counterclockwise, so when we go in this direction we can see that 32 volt, that's a rise. So let's write the rises as negative, so minus 32. Then V1, when we go in this direction, that's a drop, so that's a plus. And then when we go this minus 8 volts, the direction here minus plus, that's a rise, so that will be negative, but the voltage itself is also negative, so it will be like that. And finally this V2, when we go in this direction, that's a rise, so that's negative, so like that. So if we rewrite it, that's minus 32 plus V1 plus 8 minus V2, or if we write it like that, V1 minus V2, and minus 32 plus 8 is minus 24. If it goes on the right hand side, it becomes plus 24. So we have one equation there. We can then what we do is we look at this one here. We can see we have assigned the current in this direction, that is I. So 4 into I will be the voltage drop. In the resistor there is always a voltage drop, and the drop will be in the direction of the current. So 4I is V1. That makes sense. So from here we get I is equal to V1 over 4. Similarly, if we look at the other resistance, this one, the current is going in this direction I, and the drop actually should be in this direction, because in the resistor the drop is like that. So this one is the real drop should be negative of that. So that will be 2I is equal to minus V2, because in a resistor the drop will be always in the direction of the current, so plus to minus. So from here we get I is equal to minus V2 over 2. Now these the same I, because it's just one loop, so we can equate V1 over 4 is equal to V2 over 2, because both are I and that's a negative there. So V1 is negative of 2V2. That's what we get from here. This is our relation between V1 and V2. And once we have that, we can use this in this equation 1. So instead of V1 we can write negative V2, and that will become V1 minus, the equation was V1 minus V2 is equal to 24 there, but V1 is negative V2, so negative V2 minus V2 is equal to 24. That's negative 3V2 is equal to negative 3V2 is equal to 24, or minus 3V2. So V2 becomes minus 8 volt, and once we find that, we can just substitute here and it becomes V1 is plus 8 is equal to 24 there, plus 8 because V1 minus V2 and V2 is itself minus, so I have just directly written plus 8. So V1 becomes 16 volt. So these are our two voltages that we were after.